to my channel. In this video, I'm going to try to solve this problem called threesum, do some lab coding work, and also at the same time, I'm going to try to follow the general steps we should follow in a real coding interview. So before we start the real content for today, I'd really appreciate that if you can help subscribe to the channel. So let's first read through this problem. So given an array nums of n integers, are there elements a, b, c in nums such that a plus b plus c is equal to 0? So find all the unique triplets in the array which gives the sum of 0. So notice that the solution set must not contain duplicate triplets. So for example 1, we have 3 triplets which can make the sum as equal to 0. For example 2, because the array is empty, we just return empty result. And for example 3, it only contains one number, so we cannot really use the same number. When I say the same number, it is actually like the same element within the array. We can actually not reuse the same element within the array multiple times. So the result is also going to be empty. So let's see the constraints. The constraint says that the input array can be empty, so it can be anywhere between anywhere between 0 to 3000 elements, and each number is between minus 100k to 100k. So first of all, I think we have already understand the question. So I think one clarification question I can think of in my mind is, are you able to use the same element multiple times? So based on the description, there is no such description, but based on the example, it seems like we cannot do that. So for the edge cases, what you can think of is, suppose the input array is non-pointer, or suppose it contains no more than 2 elements, which means smaller than 3 elements, then we are just going to return an empty result. Otherwise, we are just going to go through the normal algorithm. So how to solve this problem? So the problem is pretty simple thing. So remember, we have like another simpler question, like twosum. So twosum is something like we just use 2 pointers. First of all, we need to keep the array sorted. So first of all, we need to sort the array, and then we are going to enumerate the first element, and then use 2 pointers to enumerate the rest 2 elements. So because the array is sorted, what we could do is we can keep use like the 2 pointers. If the sum is larger than 0, we are just going to shrink the right side of. If it is smaller than 0, we are going to move the left pointer to the right. So that's pretty much it about this. The runtime is going to be n squared. N is the length of the array. So let's do some coding work. So for coding, we care about the correctness, readability, and the speed. So let's get started. First of all, what we are going to do is we are going to do arrays.sorted, nums. And then what we are going to do, we are going to enumerate all the first elements. Possibility of the first element, I is equal to 0, I is smaller than nums.length minus 2 plus I. So if I would say if, so because it says we cannot really return unique, we can only return the unique triplets. So what it means is that we can, if the current number is the same as a previous number, then we just skip it. Okay, I think I forgot to do one thing, which is edge case checking. So first of all, let's get the results. Let's say it is a linked list, and then if nums dot is, if it is non-pointer, or if the nums.length is smaller than 3, then you're just going to return the result without doing anything. So that's the edge case checking. After that, we are going to first sort it and then enumerate the first element. So it would say if I is larger than 0 and nums I minus 1 is equal to nums I, then we are just going to continue, because if the previous element is the same as the current element, so possibly we are going to get duplicate result. So we definitely try to avoid that. Otherwise, what we are going to do is we are going to call the toSum to get us the result. So let's define another helper function. Let's say we have like a toSum. So the toSum is going to get us, so let's say just a void. So we say it's like toSum. So toSum, by toSum we are going to have first the pass in the nums array, and we are going to have the first number, and then when I say the first number, it's actually the pointer, and then we are going to pass in the result. I think that's pretty much it. So we are going to call toSum on top of nums, and then this is I, and then we are going to have the result passed in, and finally we are just going to result. So let's first try to finish the helper function, which is toSum. So what we are going to do is we are going to have two pointers, p1 and p2. So p1 is going to be equal to first num plus 1, or maybe we just call it second num, and then the third num is equal to nums.length minus 1, which is the end of the array. So we have this. What we are going to do is, well, the second num is not equal to third num, or if it is just smaller than this one. So what we are going to do is, if nums first num, let's say we just call it sum, as equal to the first one, second one, and the third one. Or actually, if you want to try to avoid any confusion, we actually can make it something like first IDX, second IDX, or third IDX, something like that, which is going to save some explanation. Yeah. So IDX, this is second IDX, and then this is third IDX. Alright. So if sum actually is equal to 0, then what we are going to do is we are going to have, we actually find the one solution. So one solution is equal to new linked list, one solve dot add we are just going to add the three things into the solution. So second, and then this is the third, and then we are going to have re.add the one solution. Otherwise, okay, so after that, what we need to do is we need to definitely we need to, we could just plus the second index, actually, second IDX. Else, if the sum is smaller than 0, what we need to do is we need to plus the second index, which is the left pointer. Otherwise, it means it is larger than 0. If it's larger than 0, we are just going to minus the third IDX. So that's pretty much it. Let's do some testing on top of this actually. So it is, okay, line 20. So this is IDX. Typo, let's fix it. Alright, so now it's accepted. Let's rinse through all of them to make sure. And then let's do a submission on top of it. It's run, so let's see why. So we have 0, 0, 0, 0. So actually, we are still suffering from some duplicate things. So let's see where it is. So if it is smaller than, so when we try to have like the 0 start from here, and we actually get the rest of them. Okay, so when we do the 2 sum, let's say if we put just a plus plus the second index, is it going to cause any issue? Well, so I think we are going to put minus minus the third IDX here, so possibly can actually help us to avoid this issue. Yes. Let's do another summation on top of it. Okay, so it's another issue here. So we have minus 1 0 0 2 2. All right, so actually when we, okay, so it's like when we encounter, so it's something like if it is smaller than 0, we just a plus plus index. Okay, so I think I understand what is happening. So it's like it should be something like, well, nums second IDX is equal to nums second IDX plus 1. First of all, we need to make sure that second index is so it is smaller than plus 1 is smaller than the third. So you want to ensure it is not out of the range. So if it is equal to that one, so well, it is smaller than the third index, and also if it is equal, then we are just going to plus plus second index. So I think that one we can save us some duplications here. Alright, so plus plus second index. Let's see why it is actually giving us the thing. So first of all, we have minus 1 0 and 2 here, and then what we are going to do is, okay, so this is a third index, this is a second index, so we plus, so the second index is equal to second index plus 1, so we are going to plus plus it, and then we see so when we stop the while loop, it's actually the next one is not equal, so we are going to plus plus the second IDX. Alright, so we just left one there. Alright, so I think this time you should be able to solve the issue. Let's okay, so now we have solved the issue. So it's some duplication issues. We definitely need to try to do something similar to line 48 to actually try to avoid the duplicate on the second number. So that's pretty much it about the question and about the solution. So if you have any question regarding the solution or regarding whatever, feel free to leave some comments below. If you like this video, please help subscribe to the channel. I'll see you next time. Thanks for watching.